Okay, ladies and gentlemen, so we're looking at, what are we looking at? We're looking at Chapter 3a, Pythagorean Theorem and the Trigonometry of Right Triangles. So there's going to be a number of quick videos and some quick practice for you to do. This is review for everyone. So here is a right triangle. To be a right triangle means that we have a 90-degree angle in the triangle. We're going to name the side that's opposite the 90 the hypotenuse. Weird name, I get it. Hypotenuse. However, that's what it's called, and that's what you will call it, and that's what we will all call it. And it's always, always, always the longest side. And it is opposite the 90 in the right triangle. Now, the other two sides. They're actually called legs, to be honest with you. They're called the legs of the triangle. We can call them side 1 or side 2. I like to call it just side 1. And I like to call it side 2. You can do whatever you want, but that's what I do. Now, the formula for Pythagorean theorem is one of the legs, doesn't matter which one, so side 1 squared, plus the other leg, which is side 2 squared, equals the hypotenuse squared. And we're talking about lengths there, okay? So we're talking about this length times this length, and this length squared plus this length squared equals this length squared. And to be honest with you, Pythagoras didn't really see it that way. He saw it like this. He took this side length and he put an equal length here. And what he came up with was an area. And this was area 1. And it was given by side 1 times side 1. And what they also noticed was that if they took a side length that was equal to this length and equal to this length, they got what they called area 2, and it was this length times this length, which was area 2. And they noticed that it was actually equal for all right triangles. Now that's the really freaky part, okay? It wasn't just equal for some, all right triangles. That if they take this length and put an equal length this way, they get area 3, and that area is equal to these two areas combined. So actually, the way Pythagoras saw this was to say that area 1 plus area 2 was equal to area 3. But we show it as side 1 squared, because that's this length times this length, plus side 2 squared, which is this length times this length, equals hypotenuse squared, which is this length times this length. So that's kind of interesting. That's the way they really saw it. Your grade 8 teacher used to always do it this way. The textbooks always did it this way. A personal pet peeve of mine, by the way, is that always, everybody says that the Pythagorean theorem is a squared plus b squared equals c squared. And that's all well and good as long as c is the hypotenuse. And then you can put a and b anywhere else you want. As long as c is the hypotenuse, that works. That falls apart as soon as someone like me comes along and says, well, I don't want c to be the hypotenuse. I want to be an individual, and I'm going to make that c. And that's going to be A and that's going to be B. Well, if I do that, then this relationship doesn't exist anymore for this triangle. This now has to be A squared plus C squared equals B squared. So be careful how you learn it. If you learn it with A squared plus B squared equals C squared, may I make the suggestion that you do A squared plus B squared equals hypotenuse squared. And that'll keep things straight for you. Okay, so over here, we're looking at this question. Solve for x in each of the following. Round your final answer to 2 decimals. So x is the hypotenuse. So it's going to be x squared equals 20 squared plus 27 squared, which is going to be x squared equals 1,129. But that's the answer to x squared. We want to know what number will be multiplied by itself, so there's 2 of them, to get that. So we're going to take the square root of that. And the square root of that is actually 33.60, approximately. And it's going to be in millimeters. Now, that was good enough in grade 10, and that was good enough in grade 9, and it was good enough in grade 8, but it's not good enough now. And this is going to bother you, and there's going to be whining and complaining and gnashing of teeth, and that's okay. But you now need to know that actually 2 answers here, plus or minus. And I'll explain that in just a minute. But there's plus and minus. And so I'm going to first say to you, does it make any sense that we could have a length that's negative? And you're going to say no, there isn't. There's no way we can have a length that's negative, and you're going to be right. So we're going to forget about it. We're going to get rid of that answer. That answer is no good to us. The word for that in mathematics is omit. So you're going to omit the negative. And you're omitting it because it is a length. So since it is a length. Now, omit is the word that you use when you don't use something. Like, my friends all get together and they have a party and they omit me from the party. It's very sad. I'm sad. I sit at home alone. But they omit me from the party. So, if I omit the negative, that means that the only answer left is the positive one. And that's going to be positive 33.60 millimeters. Now, where did this negative come from, this plus or minus? Well, let's take a look at an easier question. Let's look at x squared equals 9. Well, what this means is what number will multiply by itself, so there's two of them, to give 9. The easy answer is positive 3. And so we say x equals 3. But there's another answer. That other answer is negative 3. And mathematically, that means that the answer to this is that there's two answers, positive and negative 3, which means that we're going to write that as plus and minus 3. So the math gives us two answers. We then have to get rid of one of the answers because it doesn't make sense for our problem. We've seen this in the last unit. We get we get two different x-intercepts, but only one of them makes sense. Remember, we had rockets being fired, and it would hit here, and we'd get another x-intercept here, but it wouldn't matter because that wasn't the path of the rocket. This is the same idea. We're getting two answers, and you have to acknowledge that you get two answers, and then you have to acknowledge which one's right. So, over here, let's take a look. This is your hypotenuse this time. So if I'm going to use Pythagorean theorem, it's going to be 280 squared equals 135 squared plus x squared. I'm going to rearrange this just so it's nicer. I'm going to make it 135 squared plus x squared equals 280 squared. Oh, not degrees squared. I'm going to move this over to the other side. So x squared equals 280 squared minus 135 squared. And that's going to go together to give me x squared equals 60175. That's what x equals. I need to know what x squared equals. So 60175 square rooted. X is going to be plus or minus 245.31 because that 5 makes a 0. That 5 makes a 0 round up to a 1. And we're going to omit the negative. Now I'm getting short form here, so omit neg is good enough. And we're going to say x equals positive 245.31 meters, which means that this length is 245.31 meters. And yes, I know you're whining and complaining. I know you're saying I never had to do this before. Now you do. I want that step. Don't miss it. Okay, stop there. Do the questions on the back of this sheet, and we'll be back in a minute.